This engine costs just under $10,000, and it just copied a design Suzuki spent decades perfecting. That's not marketing hype. You can see it in the hardware. The feature exists. The pricing is real at $9,895. And the Suzuki DF115 it's copying sells for almost the exact same price, at around $9,369 to $9,495. Here's what we're solving. What the specific feature actually is, why Suzuki protected it like industrial IP, and what happens when a Chinese manufacturer uses it without the surrounding infrastructure. By the end, you'll know whether the Parson F115 is a genuine alternative or a trap disguised as savings. Let's start with why Suzuki matters in outboard engineering. Suzuki didn't build their reputation on horsepower bragging rights or flashy digital displays. They built it on engines that survive operator neglect in hostile environments. Fishermen report putting over 6,000 hours on Suzuki outboards, including their larger models, running them in saltwater, missing oil changes, and expecting them to fire up after months of storage. That's not luck. That's deliberate engineering for predictable degradation. Suzuki designs assuming you'll be late on maintenance. They assume you'll push service intervals. They build engines that limp home instead of leaving you stranded 20 miles offshore. That tolerance shows up in specific mechanical choices. Most buyers never notice until year 7, when their buddy's engine is being rebuilt and theirs is still running. Here's the part most buyers never notice until years later. The features that extend engine life aren't the ones in dealer brochures. They're buried in oil pathways, cooling redundancies, access panel designs, and components that don't photograph well for marketing. Suzuki engineered an offset crankshaft design, where the crankshaft is positioned forward of the driveshaft, moving the outboard center of gravity forward and significantly reducing vibration. This isn't new technology for Suzuki. Their offset crankshaft design has been proven across their lineup, from small portable engines to larger models, reducing engine vibration and improving fuel efficiency. And this exact feature just appeared in the Chinese-built Parson F115. The feature is an offset crankshaft geometry. Here's what that means in plain language. Most budget outboards mount the crankshaft directly above the driveshaft in a straight vertical line. It's simple. It's cheap to manufacture. It's been done that way for decades. But it creates concentrated stress loads and limits how effectively you can route cooling passages around high temperature zones. Suzuki's design positions the crankshaft in front of the driveshaft, which moves the outboard center of gravity forward, making it more compact and increasing performance while significantly reducing vibration by moving the engine's axis of inertia up over the upper engine mount. The result? Lower operating temperatures, reduced thermal stress on gaskets and seals, smoother operation, and longer intervals between failures caused by heat cycling. This looks simple. It isn't. Shifting the crankshaft changes every internal dimension. The engine block has to be completely redesigned. The lower unit mounting angles shift. The power head attachment points move. Every tolerance stacks differently, and if you get one measurement wrong by a fraction of a millimeter, you don't just lose efficiency, you create harmonic vibrations that destroy main bearings in a quarter of their expected lifespan. Suzuki didn't rush this feature to market. They validated it across thousands of test hours, mapped thermal stress patterns, documented failure modes, and built service protocols so technicians could diagnose problems without trial and error guessing. Now watch what happens when a manufacturer skips that validation process. The Parson F115 uses what they call an offset crankshaft design. The geometry looks similar. On a teardown, you'd see the crankshaft positioned forward of the driveshaft. On paper, it replicates the concept. But here's the twist nobody talks about. Copying the feature is straightforward engineering. Copying the consequences is a completely different problem. Let's talk about why Suzuki protected this design philosophy for so long. Legacy manufacturers operate under brutal warranty exposure. When Suzuki releases a new feature across their lineup, they're accepting financial risk on tens of thousands of engines. If the design creates unexpected failures, they're replacing powerheads, paying dealer labor claims, and damaging relationships with boat builders who spec their engines. That risk makes them conservative. They don't ship a feature until they've stress-tested edge cases and built diagnostic trees for every failure pathway. A feature that works 97% of the time still generates hundreds of catastrophic failures at manufacturing scale, and every catastrophic failure costs more than 3 engines worth of profit margin. Chinese manufacturers operate under a different risk structure. Their domestic market has historically tolerated higher variance in exchange for aggressive pricing. Speed to market drives market share. They assume owners will handle minor repairs themselves or use local service networks with fundamentally different labor economics. That's not a moral judgment about business ethics. It's a structural difference in how warranty risk gets distributed between manufacturer and owner. The problem emerges when that product enters markets with radically different service expectations. Western boat owners expect dealer support. They expect technical documentation in English. They expect parts availability that doesn't require international shipping and customs delays. When those infrastructure systems don't exist at the same depth, the unexpected engine becomes expensive very quickly. Don't click off, because this is where the math changes. The feature itself works. Bilham Marine, a UK dealer, tested the Parson 115 over 6 months and reported it demonstrated exceptional performance and reliability, with one test showing the engine consuming only 20 liters per hour at cruising speed, even with 8 passengers totaling 600 kilograms aboard. In controlled conditions, the offset crankshaft delivers measurable thermal benefits. Early adopters in regions with strong Parson dealer networks report satisfactory experiences. The problem isn't what you see in Season 1. It's what shows up in Season 4 when a seal fails and your local marine shop has never opened up this specific block configuration. Here's what Parson got right. The core geometry transferred. The F-115 features all-aluminum design without cylinder sleeves, 4-cylinder inline configuration with 16 valves, common rail injector, electronic multi-point fuel injection, and twin camshafts driven independently to improve intake and exhaust efficiency. If you run this outboard in light recreational use with attentive maintenance and regular oil changes, you'll likely see the thermal and vibration benefits the offset design was meant to deliver. The engine runs smoother than straight shaft competitors at the same price point. In theory, it extends component life, and at just under $10,000, that's compelling if you understand what you're actually buying. But here's the knife line. Cheap engines don't ruin people. Fragile support systems do. The offset crankshaft only delivers long-term value inside a comprehensive support structure. Suzuki didn't just design the crankshaft geometry, they designed the diagnostic software, the service manual depth with torque specs and assembly sequences, the parts distribution network, and the technician training programs so that when something goes wrong 15 hours in, it gets diagnosed correctly and fixed with the right parts the first time. The Parson F-115 has the feature, it doesn't have the ecosystem, and that gap is where your money disappears. Let's break down what didn't copy over. First, material batch consistency. Suzuki specs their aluminum alloys with tight composition tolerances and specific heat treat processes that ensure uniform hardness across production runs. They test batches. They reject castings that fall outside spec. Parson uses similar alloy families, but independent analysis suggests batch-to-batch variation runs higher. That means one engine might handle thermal cycling beautifully for 3,000 hours, and the next unit off the same production line might develop stress cracks under identical operating conditions. You won't know which one you bought until it matters. Second, machining precision at tolerance stack-up points. The offset crankshaft requires exact alignment across multiple mating surfaces, the crankcase halves, the bearing journals, the cam timing. If those tolerances drift even slightly during manufacturing, you get asymmetric wear patterns on bearings. You get oil starvation in specific journals. You get failures that look random but stem from production variance. Suzuki's manufacturing QC catches drift before engines leave the factory. Budget operations don't always invest in the same statistical process control. Third, and this is absolutely critical for ownership cost, failure mode documentation. When a Suzuki engine develops a cooling issue, there's a diagnostic decision tree. Technicians know which thermostats fail first, which hoses crack predictably, which impellers degrade at specific hour intervals. They've seen the failure pattern across thousands of identical engines. With the Parson F-115, you're in unmapped territory. Your local mechanic is guessing. Is it the thermostat, a casting porosity issue, a sensor calibration problem, an ECU mapping glitch? Without documented failure histories, diagnosis becomes trial and trial and error at $75 to $90 per shop hour adds up faster than you think. This is where owners get confused and dealers get nervous. A customer brings in a Parson F-115 that's running 10 degrees hotter than spec. The offset crankshaft is supposed to prevent exactly this problem, but the technician doesn't have a baseline for this specific engine architecture. Parts have to be identified by photographing components and emailing suppliers in China. Lead times stretch into 3 to 6 weeks for anything not in the basic maintenance catalog. Every day your boat is down costs you fishing days, charter income, or family weekend plans. Here's a real ownership scenario built from actual user reports. You buy the Parson F-115. First season runs flawlessly. Second season, you notice slightly elevated operating temperatures. Not critical, just higher than the manual specifies. You take it to your dealer, they can't source the exact replacement part, and none of the local outboard repair shops have manuals or carry spares for Parson. They try a universal thermostat that physically fits the housing. It works, but now the ECU throws a code because the resistance curve doesn't match what the engine expects. You're 4 weeks into the problem, $600 into diagnostic labor, and the engine still isn't running right. Your initial savings just evaporated and you haven't even hit a major component failure yet. Now let's talk about resale value, which doesn't show up in year one but defines total cost of ownership. Suzuki outboards hold their value well due to the brand's reputation for reliability, and well-maintained Suzuki outboards perform strongly in the resale market, particularly in regions where Suzuki service is readily available. A used Suzuki sells quickly because the next owner knows they can get it serviced anywhere. They trust the parts supply. They understand the failure patterns. A used Parson F-115 with a copied feature? You're selling into a narrow market of buyers willing to accept the same service uncertainty and international parts sourcing you dealt with. That uncertainty compresses resale value. You'll take a steeper depreciation hit when you try to exit. But here's where it gets interesting. The real problem isn't Parson as a manufacturer. Parson engines are priced up to 30% cheaper than other brands in some markets. The problem is the buyer who doesn't understand what they're purchasing. If you go into this knowing you're buying hardware without comprehensive infrastructure support, and you're comfortable sourcing parts internationally, doing your own diagnostic work and accepting compressed resale value, the math can work. You're trading money for self-reliance and mechanical aptitude. That's a legitimate choice for someone with marine engine experience and time. The trap is for the buyer who thinks they're getting a Suzuki equivalent experience at the same price point. They're not. They're getting Suzuki-adjacent engineering with a fraction of the support ecosystem. Let's zoom out beyond this specific engine. Why does this matter? Because it exposes the real cost structure of marine equipment. The feature itself, the offset crankshaft and optimized cooling pathways, represents maybe 25% of the total value proposition. The other 75% is validation testing, comprehensive service documentation, parts distribution logistics, technician training programs, and warranty claim processing infrastructure. When you buy a Suzuki DF-115 for around $9,369 to $9,495, you're not paying extra for better aluminum. You're paying for certainty. The certainty that when something breaks at 1,500 hours, you're not starting from zero. You're paying for the dealer network that keeps your boat running instead of sitting in a storage yard waiting for parts shipped from Suzhou. The Parson F-115 proves something important about modern manufacturing. The engineering gap is closing rapidly. Chinese manufacturers can reverse engineer advanced features. They can deliver performance metrics that look competitive on specification sheets. They can hit price points that seem impossible. But the service infrastructure gap is still wide. And service infrastructure is where reliability actually lives day to day. An engine that runs perfectly for 2,000 hours and then becomes unsupportable in your region is not a reliable engine. It's a time bomb with a long fuse. Here's your decision framework. If you're buying an outboard for a remote location where the nearest dealer is 3 hours away and you already do your own maintenance and fabrication work anyway, the Parson F-115 might make sense. You've already opted out of the dealer service model. Your risk profile is fundamentally different. You have the mechanical skills to troubleshoot uncommon problems. But if you're a weekend recreational boater who relies on professional service, who needs parts tomorrow instead of next month, who wants to sell the boat in 5 years without the engine being a liability on the listing, the Suzuki isn't overpriced. It's correctly priced for the value it delivers across the full ownership curve, including resale. And here's the larger truth nobody wants to say out loud in dealer showrooms. The feature doesn't matter if the system fails around it. Suzuki didn't win market share by inventing one clever design element. Over the decades, Suzuki was awarded Most Innovative Products from the National Marine Manufacturers Association several times between 1987 and 2017. They won by building an ecosystem where innovative designs could be maintained, diagnosed, repaired, and trusted over decades of use. The offset crankshaft is genuinely good engineering, but it's functionally worthless without the infrastructure to support it when something inevitably goes wrong. And in marine engines, something always goes wrong eventually. The surprise isn't that Parson copied Suzuki's offset crankshaft. It's that Suzuki proved which features actually matter to long-term ownership value. Not the headline specifications, not the horsepower-to-weight ratios. The features that matter are the ones that keep you on the water when everything else would leave you stranded or broke. Parts availability through a local network matters. Technician familiarity with failure patterns matters. Comprehensive diagnostic documentation matters. Warranty response time without international shipping matters. These elements aren't exciting. They don't create compelling Instagram content, but they're the difference between a tool that serves you and a liability that costs you. So here's what you do with this information. If you're seriously considering the Parson F-115, ask these specific questions before you buy. Where's the nearest marine technician who has actually torn one down and reassembled it? What's the parts lead time for common wear items like thermostats, impellers, and gaskets? What happens if the ECU fails and needs replacement or reprogramming? Who has the diagnostic software and cables? What's the realistic resale market like in your specific region? If you get confident, detailed answers backed by actual service records, proceed carefully with your eyes open. If you get vague answers, blank stares, or promises to figure it out later, you're not buying an outboard engine. You're buying a project that will teach you expensive lessons about marine service infrastructure. Cheap engines don't change the game. Understanding which features actually matter does. Parson didn't steal Suzuki's secret engineering. They proved Suzuki was right about what creates reliability over thousands of hours. The offset crankshaft reduces vibration and improves thermal management, but only inside a system designed to support it when things go wrong. And that's information you can use whether you buy the copy or pay for the original. The choice isn't about patriotism or brand loyalty. It's about honestly assessing your mechanical skills, your service access, your usage patterns, and your exit strategy. Answer those questions truthfully, and you'll know exactly which engine belongs on your transom.